Heat sealing through contaminants can be frustrating, especially on high-speed vertical form, fill, and seal. I'm going to identify the most challenging contaminants and what resins have the best chance of sealing through them. Water and oil are non-starters. These are the problem children. Flour, cornmeal, cornstarch, and especially cocoa and powdered milk. Now, if you're packaging what's called complete mixes, either for consumer or institutional, it's an ordeal. The sealing layer has to be right. To draw the contrast between the different resins, I came up with a protocol. I mixed all these in more or less equal proportions, sealed them with the seal layer deliberately contaminated. The resins are general purpose clear polyethylene, a high density polyethylene, a very low density metallocene, and polypropylene. Now, just for fun, you might pause to ask yourself what you think is going to happen. Well, let's see what we got. High density, which is basically this material here, is the outer layer of a what's called chip film or cereal film. It's comprised of an outer layer of high density polyethylene and an inner layer of very low density metallocene or EVA. Now turn it inside out to prove a point. Let's see what happens. That doesn't do so good, does it? Now, wherever there's a lot of contaminants, nothing's really going to seal through it. So you get the general idea. Well, that one did pretty good, but it's not very contaminated. Next, let's look at polypropylene. Ooh, that's not good at all. It just fractures right away. Polypropylene is usually the outer layer of a lamination. Then you have a low density for the inner layer. Now this is a general purpose low density polyethylene. It's not a linear low. And you can see that it's doing a lot better, especially, well, see there's a lot of contaminants and not a very good seal. We go to this one and yeah, it's getting better. It's improving. Oop, not very good there. And now we go to a 903 density metallocene. That's very low in density. Let's see what happens here. That's pretty good. I see there was a lot of mix on that. Now, when you're running a vertical form, fill, and seal, the heavier particles are going to drop, but no matter how you adjust your hasten, your Illipack, or what have you, there's going to be some dust that's going to be left behind. That's what gives plant managers headaches. Results and discussion. The molecules which are more or less linear, which would be high density and polypropylene, did not seal that well. That's because they have very much short chain branching and not a lot of random branching. They also had very high heat resistance. The lower we go in density, the better the seals were. So what this means is that the molecules which are more like burled wood instead of wood that's more like ash that has more of a grain to it, the lower density, or the ones that are more of a mishmash like spaghetti after it's cooked, are going to seal a lot better. Now, a few fine points. You say, well, polypropylene. I mean, look, this is polypropylene and this is polypropylene. I mean, look at these great seals. You got a nice looking quad seal on this bag. Well, that's really a hybrid because it's a core layer of polypropylene with the outer layers of polyethylene. Think of it as the polypropylene as the meat and the polyethylene as the bread part of a sandwich. Now we're talking about very, very small amounts of polyethylene, maybe 3 microns, 4 microns. If you just to put this in perspective, a micron is 1/25th of a mil, or 1,000th of an inch. If you wanted to see an example of this, very popular structure is ExxonMobil Bicor ABX. Another thing, if you notice, the jaws have a lot of areas where you can trap the contaminants. That's why we can get lots of different varieties. The executive summary: make sure that the sealant layer of your lamination or your co-extrusion has a very low melting point, preferably with some metallocene or EVA. For more information, you can look at the Form Fill Seal troubleshooting guide on our apps page. If you want to have more information about why metallocene or EVA works, you might watch my video on frozen food packaging. Bon appetit.